Hello, everyone. Good afternoon. It's a pleasure to be here on the ABP conference. My name is Gleidson Nascimento, and I'll be talking about something very dear to me, which is Kubernetes. Um, I hope that you take a lot of the conference and particularly of my slides, and I'll make sure that they'll be available to you at the end of the presentation. This all started around 1 year ago, but I remember as if it was today. I was actually come home from the gym. It was a rainy Thursday, and I saw this question in our community by someone that I didn't know, asking around for anyone that had already deployed to production with Kubernetes and ABP on Azure. This is nothing I had not done before, but at that time, I was already taking care of one application, a simple application that was using ABP. So I confidently replied, "Oh, yeah, it's lots of fun." And it really is, right? Barely I knew that this go to production tale would be so full of action, thrills, plot twists, roller coasters, and a 78-hour non-stop attempt to get one deployment done in Kubernetes. Because one thing is getting your code built and delivered in an environment called production. But another thing completely different is shaping up your application for prime time. At that point, you get questions like, how do we make our application secure for its users and its engineering team? How do we grow it to be scalable? How do we reduce the latency and the load times? How do we do all that respecting the development experience? Those are hard questions. Those are important questions. And although I had experience with ABP source code, I was about to find out, how do we scale the terminal on Kubernetes in production? Or actually, how do we scale ABP framework on Kubernetes in production? But first, let me introduce myself. As I said, my name is Gleidson Nascimento. I'm advising at urvin.finance around DevOps and SRE and cloud, but I'm a community builder. I'm an open source contributor. I have contributed in many projects like Goa Design and Molecular. They are all Golang projects. I'm also a startup mentor. I have here my social media if you want to follow me or check some of the cool stuff I'm doing. And I've put here a few presentations as well of previous things I have spoken already about the cloud. So the team I represent here today, Urvin Finance, they created the terminal. The terminal is a tool to empower individual investors with education, community, data, and tools necessary to level the playing field and making you, the retailer investor, to prosper. With the terminal, there will be provided education for financial proficiency, so you understand the terms and the objectives, tooling for providing you direct access to exclusive data, data that it is usually paid for those big hedge funds, and a platform for financial communities to gather together and grow as a group. Right now, the terminal has 1,500 users in closed alpha, and we expect to launch our beta version in a few more weeks. So if you want to hear more about it, or if you want to know more about it, you can go to our website, which is www.urvin.finance, or you can just subscribe to the mailing list in the website. You can ask me at the end of the presentation. I'll be more than happy to talk to you guys about our roadmap. Okay. So we knew what our application required. We knew what we had to do to reach the objectives I just explained to you. We want data to be available blazingly fast. We have to have tools that are easy to use and very very easy to maneuver and to manipulate. So you can create complex data demonstrations for your peers or even trade. So those things, guess what? They require the same kind of things that any mission critical application requires. So what I'll be presenting here, right? This whole journey, I expect that you can take our lessons in doing that using ABP and have as a fruitful journey as we had when you deploy ABP to production. But let's talk a little bit more about our particular setup. So our architecture contains a financial module. The financial module is responsible for obtaining and displaying security details. We also have a community module, and this community module will be peering users through communities, through posts, and through mentions. And finally, we have an intelligence mode, and this particular module will be responsible for processing data and making those beautiful visualizations that the terminal offers. So in here, you can see an example of how this all comes together in our core UI component. And this core UI component is exactly where the magical integration happens. That's where we make it possible for those separate modules to collaborate and spotlight the information, the data, the news, and now that cool stuff that is available to you on the terminal. So, in order to deliver all of this, the team has decided to invest in a license from ABP Pro. By default, ABP Pro provides pre-built application modules. It also provides advanced startup templates. It provides rapid application development tooling, professional UI teams, and even premium support as per their website. So to us, this was a way, because we are all .NET specialists. So to us, it was a way to get a good head start on something very valuable to us. These microservices startup solution. We knew that we would be breaking up our monolith into microservices and having them doing what they do best separately from the others. So with this solution, we had a complete architecture made of microservices fronted by an API gateway and with databases as data stores and also caches. This allowed us to build a scalable solution from the ground up. These microservices, they were all created together with another feature from ABP Pro, which is reusable modules. Those modules can do things like accounting, auditing, identity management, among other stuff. These really provided us an amazing head start. And this head start to, to development allowed us to bring the terminal up to the level where we thought that its alpha state should be. We spent a few time developing the modules and preparing the integrations to partner services and obtaining news. We did all of that using ABP Pro application modules. Now, as we had a few things happening here and there, we ended up with a few microservices in a monorepo. And bringing things up required running a few things in parallel. It required coordination, a little bit of patience because it was starting to get a little bit heavy. And we also required a lot of prerequisite software. Sometimes we had to increase our resources in our virtual machines in order to get everything up and running correctly. At that point, we went to ABP and they provided us some guidance on how to bring things up, right? You can see here the samples pages from ABP. They they have very good examples like using Docker Compose and other solutions for developers to execute locally the source code and bring up the prerequisite software even doing that before bringing up the application, for example. So we went through that and we attempted to bring the application up a few times. And although we could get things running, it wasn't enough. And at sometimes we felt that the development experience wasn't good. It would take time for developers, for example, to bring things up and find out that there's something wrong that needs to be remediated. However, they had to bring things down to change the source code and bring things back up. So at that point, we decided to rely on TIE. TIE is an experiment from the .NET Foundation team. They are created with the objective of easing development, testing, and deployment of microservices and distributed applications. ABP even adopted TIE on its standard microservices example in GitHub later. But we saw TIE as an opportunity for us to first and foremost make development easier. But the idea of having help on the microservices was actually a very cool feature as well. So TIE comes first with an orchestrator, and that makes running and watching changes on many microservices easier with a single TIE command. You would do TIE run, and your project would come up in the right order with the right ancillary services. Um, there is a cool UI that you see here. That UI allows you to see the running project, watching logs in real time, and other things. As you do changes in your source code, TIE captures that and automatically restarts that particular microservice to refresh what you would see with the changes you have made in the source code. Finally, TIE provides at that level of orchestration service discovery capabilities, making it possible to find out about all the services with simple conventions, very simple conventions. On those areas, TIE shines and really improves development experience. We had a huge help, a huge push forward by adopting TIE in our stack. On the other hand, TIE was also designed to deliver application to Kubernetes. With TIE, according to the website, you would get automatic containerization of your source code, generation of Kubernetes resources, and even deployment into clusters. All of that using the same conventions currently used for developing your application. Or so we thought. TIE, as I said a while ago, is actually an experiment. So TIE met our development expectations, but it was actually far away from our delivery expectations, to a point where development productivity was very good, but it simply wasn't possible to push application updates to environments. Just so you can make a clear idea here, the latest update from TIE team in late December was that they would start again to merge changes and attempt to release a new version. That didn't happen yet. And the latest version of TIE released was 15 months ago, which to us in IT is an eternity, right? So at that point, we realized that we had to, let go ABP from TIE in order to reach production differently from what we saw at first. That was our first lesson, to not use TIE in order to reach production. So this disconnection between how developers were doing to run the code and how the actual environments were prepared is important, because it is fundamental in a DevOps idea that you do things the same way every time. So this disconnection meant more work to us, but it was important to keep the values that TIE brought to our development experience and try to find a way to get that into production in a way that would make sense to us and to the developers as well. Um, That meant we had to find middle ground between how easy it would be for developers to progress their code and how simple it would be for that code to reach production. And how we achieve that? We achieve that by using Thai to create the target elements to be deployed and then shaping them to our needs using Kubernetes elements like Helm, for example. This could be achieved, as you can see the source code here, by defining the container details such as registry and network and all the Kubernetes elements like namespaces and service bindings. That was what made us possible to bridge the discrepancy into how Thai was good with development experience and how Thai was lacking on Kubernetes deployment. So in principle, it had to be it. But you know what? It never is, right? We were still not able to run the application in Kubernetes because turns out that Thai in the end was enforcing SSL, as you can see here highlighted in the config files with the key stores. Obviously, our certs were self-signed, they were prepared by the .NET tooling, and they were generated only for development purposes. Also, in ABP's gateway, there is a definition of APIs where the listening host in the backend is defined. So APIs and API calls to services can be proxied, can be authenticated, authorized, and routed accordingly. This is done on the API gateway delivered by ABP. So if you are developing in your computer, in your own development laptop, that host is localhost and it's fine. But in Kubernetes, we have to have this host defined as per the Kubernetes services and the service discovery layer that is defined in the namespace you are deploying. However, Thai service discovery doesn't refresh that required settings in app settings, right? So those backend services could not be discoverable in our project when running them targeted into Kubernetes. Finally, the experimental status of Thai meant that we had to figure out a lot of things ourselves in order to progress with many things that were supported but not documented anywhere in the GitHub docs, issues or published examples. To an extent that, for example, our final Thai file has probably 30% of documented items in Thai and around 70% of things that are available in Thai, but they're not documented anywhere. We had to literally read the code. We had to figure out by going to Thai source code, reading how things are done, and find out how to prepare the Thai file so that would happen as we were expecting. And finally, for other things, we actually had to stop and skip Thai completely and deal with it ourselves, right? So at that point, we concluded our second lesson learned. Um, Not every abstraction is productive. Sometimes abstraction they can make it easier for you to adopt tooling. It makes it easier for you to achieve goals, but we should always pursue abstraction that matters, abstractions that are productive, that makes your performance productive, that enhances your development experience, right? It's a very subjective topic. It's really a subjective topic because what is important for me in my performance, in my development experience, might not be as valuable as it is to you, right? But we need to remember that regardless of what choice we make, right, we should always prioritize the good values your team has, as I prioritized the values that my team had. And we should use the abstraction to enhance and empower that exact values that you see in your team. So we dealt with all those issues in the right way that each one had to be dealt with, right? But you may ask, how did you do that? It's again another subjective topic. Many people have written about this. Many people have even created books about it, publishing about this topic. You can see one here by O'Reilly. So Being truthful to our lesson learned, we follow the best practices, but to a way that enhanced our productivity while sticking to the basic mandates of uh, um, of when you work with Kubernetes, right? But what are those mandates? They are written in the book. You can get the book from Amazon and read more about it. I'll share a few of the things that we have done. The first one is a core value at urvin.finance, which is security first. We only run trusted containers in our infrastructure. We force them to run on a read-only file system, and we force them to run as a non-root user. This ensures that no additional permissions would ever be granted in a scenario that a threat actually sneaks into our infrastructure and attempts to elevate its permissions. Because remember, by default, things run with no permission at all. We also use role-based access control clusters, always, to make sure that our audit logs contains always all the relevant information. So tracing and finding out what could be happening at the cluster at any moment of time, it's easy and simple to us. The second best practice that we used in our Kubernetes clusters was based on DevOps feedback loops. We use namespaces to group our workloads. This makes sure that what we're doing for one namespace stays in that particular namespace. So we can experiment, we can easily add new services, we can find out how new configuration should look like without interfering with other namespaces and even in other clusters. We always, this allows us, as I said, to group these workloads accordingly, right, to what they are supposed to do. But we always label them with meaningful descriptive tags. So it's easier to target them with our automation process. And we always use readiness and liveliness probes to verify at all times that our microservices are operating as intended. This gives us the required telemetry for always understanding at a point in time what's going on within our systems in each of our microservices and on the overall the terminal. The final best practice that we adopted was around resource control and capacity planning. Very often, you size up your application, you prepare cluster to support that particular application, but then you find out that containers can't be scheduled properly, but there are resources available, and the resources can contain those containers, but somehow things don't go properly, right? Most of the time, this is because you're not taking good care of your capacity planning, right? So what we did, we applied infrastructure controls such as affinity and anti-affinity. These assures proper balance of workloads, so they either stick together because it makes sense for them to be as close as possible, or they are far away, so we have high availability in a scenario for deploying a new version, for example. Um, Also, we adopted node taints and tolerations, which allows us to control how the scheduling happens. So it works in scheduling first, the critical workloads we need running first, so we can bring up the terminal. We can bring up a new version of the terminal. We can create a new environment for times of high load in our systems. Um, then we defined limit ranges and resource quotas to ensure that any new services that are already shaped up to the environment will belong there. They will fit there. They will actually be contained in that piece of CPU memory we expect that container to occupy. Uh, this makes sure that auto scaling happens, and it happens according to actual real time load, right? So you don't have new nodes or new containers created, out of the blue. They actually happen because there's actually load happening in our front end systems, in our systems overall. That created to us environments with optimal usage and complete control of costs and capacity. After that, we got production up and running. Yes, it was amazing until we attempted to sign up and log in. Things were slow, they were sluggish. We felt as if there was an anvil tied to the website. It was very, very, very hard. Um, we were sure that things were properly set up, they were correctly sized. So, we had to go back to the drawing board to find out, to understand what could be the reason behind that slowness, right? The first place to look at was our source code. At that point, we spoke to ABP support again to guide us on points of improvement on our website. And they pointed us to the documentation explaining how to configure items for production. And when I say items, I mean lots of items that can be configured and fine tuned in the source code, like caching and logging and locking of data stores, among other stuff. This is all documented in ABP's website. But also, they have a collection of references for clustering components, for running distributed microsystems, and even how to optimize things when you actually get the production environment up and running. And this was exactly what was missing in our case. Um, we had looked at those things on development time, but we had to revisit them again when speaking to ABP support. Um, I would like to emphasize that I said the word reference here, right? The references were provided by ABP. So they had references for us to follow and enhance our application for prime time. After working on the source code, we had to investigate our cloud provider. We had to research where there was room to improve our initial setup. We are using Azure Kubernetes Service, which is a managed cluster solution. On a managed cluster solution, you only create the node pools. Azure takes care of the control plane. So obviously, we were using arguably the most fast Kubernetes solution available in a cloud provider. If you create your own Kubernetes cluster, you are binding your control plane to how big or how small your virtual machines are. When you use a managed cluster solution, you are putting your control plane in the fastest way possible. Then it's all about how your node pools are set up, allegedly. We had to work out with the support team to find out the best outcome on on how we could achieve low latency. Also, how we could achieve optimal cloud costs, because there will be no reason for us to run massively big machines, right? When all you want is just low latency, maybe tweaking the networking layer could achieve the same result. So we will try to find this optimal spot between cost and speed. But luckily, Azure provides a collection of reference architectures for most of its offerings. Use the word reference one more time. The reference architecture for AKS contains the baseline according to its design principles and best practices from the Azure well-architected framework. You can see that I was pointed to references by both ABP and Azure. So not only we had to make sure that we have read the documentation and followed the best practices and design principles of the technologies we chose, we also had to make sure that we were doing our work in accordance with the provided reference architectures that those technologies provide. This was our lesson learned number 3. Those reference architectures, they are battle tested. They are a reflection of what works better and what doesn't work when using those particular technologies. They are designed to make sure of you using what works better to take the most of the technology that you are using and achieve the optimal operation. So, from the reference architectures on Azure, we had to do a few updates in our infrastructure. The first one was adopting a hub spoke pattern for our VNet and our web application firewall. We did not adopt traffic, which was suggested by Azure, because at that point, and we still believe that, but at that point, we realized that the benefits were not outweighing the disadvantages of having a more complex way of routing communication within the namespace. So we did not adopt traffic, but we implemented the hub spoke idea of VNet and web application firewalls, and that was a good improvement. Second thing we done was rely on certificates provided by Key Vault instead of Let's Encrypt. It's actually a very interesting one because you can use Let's Encrypt and you can get free certificates. They are very easy to set up. They support pretty much every major DNS provider. It's very simple for you to generate certificates on the fly for anything, for wildcards, for web services, for even TCP applications. Very simple to use them in Kubernetes. But by moving the certificate out of Let's Encrypt inside Key Vault, for our case, we were doing the TLS and the SNI, 7-name identification. We were doing both of that outside of AKS. And not only this is a cool security feature, this also means that we are retrieving and verifying certificates on the Azure compute, not on the cluster compute, not on the node pools. And this is actually faster and more fault tolerant, particularly in heavy load moments. And the third and probably the most important decision was implementing Kubernetes service discovery and relying on the native DNS entries of the cluster instead of using our own private DNS zone. That meant that we had a way to implement sticky sessions, to implement round robin and canary deployments without the use of extra software like traffic, for example. But without the private DNS entries, by using the Kubernetes cluster DNS, right? It was possible to bridge how routing happens locally with TIE and with Kubernetes. We made it possible for this idea of users using the application, bringing them up in the same way that they are brought up in TIE. It was a good thing. It was a really cool feature, and that really helped us with verifying network performance of the microservices outside of Kubernetes. So I'll show you here some results after working things out. You can see on the two latest pictures how we were able to actually tweak the code and infrastructure to reduce up to 10 times the latency on the 95th percentile and the 99th percentile of performance. You can also see on the other two pictures on the right that we were able to optimize the CPU and memory consumption across containers. And that actually shows that we don't have any more pods stealing processor or memory from one another. Even after bad jobs, like the screenshot shows, you can see on the screenshot for CPU that we had a huge spike of processing, but the other pods didn't suffer it at all, and we had no impact on memory usage. So this shows that we have actually optimized how CPU and memory were consumed by those containers. So overall, this was a very, very fun journey. We have learned a lot while bringing this up. And we believe that what we have done here can be similarly applied for any application developed using ABP. So if you have questions about our approach, you can ask to me now. We can meet at a room later to discuss in details what we have done, some of the things we have done here. So by all means, please reach to me. Please preach to us, okay? Um, our approach here, as I said, was backed by a strong DevOps philosophy. If you don't know about it and you want to know more about it, I recommend those two books. We also recommend you reading the AKS reference architecture because it contains a lot of knowledge on DevOps methodologies inside that reference architecture. And this is it. I hope you have a great conference. I would love to hear your questions if you have any. Okay, so the first question is there a reason why ABP doesn't have a module in the style of the DB migrator, which generates the Kubernetes YAML files using the Kubernetes NuGet? I don't know who asked that, but that's actually a very, very good question. Turns out that, to the best of my understanding, ABP created actually a Helm chart. So the idea is that you use the Helm chart to generate the Kubernetes YAML definitions today, right? But the Helm deployment is as flexible as it is the development of the templates, and they only provide you with a sample repository, right? They are not generated in flight, for the best of my knowledge, right? You actually get the template and you develop on top of that to reach how you want things to look at. In the end of the day, you need to understand that you can either have a push a push idea where you create new containers and you just point them to Kubernetes by doing set image minus minus record, and then that new image SHA will be recorded to your deployment, and you'll get new containers. This is a push strategy, but you also have a pull strategy where you put code into Git, and then the tooling, probably a GitOps thing like tool like Flux or Argo, will read your code and create the containers and refresh the deployment descriptions for you. Each side has pros and cons. If you do a push strategy, probably you need to find a way to maintain any environment variables you have in your application. On the other hand, if you take a pull, probably you will use more time to get applications delivered to Kubernetes because you need to wait for your checks in Git and your checks in Argo or Flux. So, as I said, it's a very subjective point, but it would be great to hear from AVP why they decided to do Helm instead of the Kubernetes NuGet. But to the best of my understanding, if you go today to the sampling on distributed applications, that's what you will see there. You will see a sample that uses Helm to bring things up on Kubernetes. I hope I have answered the question. Okay, if not, let me know. Okay, next question. For a startup with cost being a concern, would you recommend pushing the testing MVP to Azure or making a single local node Kubernetes for testing node? How painful it is to scale from local to cloud later? It's actually a very good question. The team, before my arrival, had attempted to run things on a local Kubernetes. And the local Kubernetes is as good as your laptop is. You have a very good laptop, you have a massive machine, your Kubernetes will be so big and you'll be able to add uh, more resources to it. Uh, um, you can add more features from Minishift, for example, or K-trees. You can add more features to it, so it'll be closer to what you would like on production. Whereas if a laptop is not as big as you would like, then you need to run that very minified Kubernetes version for local Kubernetes. So in our case, as I said, they had attempted that and that didn't work. It wasn't because of local Kubernetes. It was because of the issues I mentioned earlier with certificates and with the definition of services and all the stuff. So we actually started by doing that exactly on Azure, right? I started day one building things on Azure. So it was not painful to me to scale it. What I would say to you though is that if you were using local Kubernetes, and for example, you were using the Helm example I mentioned on the previous question, if you do things that way, it will not be painful to bring cloud up. It will be painful probably later to figure out if a particular microservices requires more or less resources because in local things are so tiny and it's just you using that you might not be able to create as much traffic as you would like to see how big or how small a cluster should be. So yeah, in my thinking, I believe that it makes sense to try and scale as early as you can, even if you have to create what is called a single node cluster, right? You can create a single node cluster on Azure just to bring things up, do a quick run, then tear things down. And that would help keeping costs at bay. Okay. Hope I have answered the question. Do we have more questions? Okay, from Peter Reynolds, thank you. For scaling factors, would you recommend SQL inside or outside of Kubernetes? Another very good question. I'm a big OpenShift enthusiast, right? I'm part of the OpenShift community. I'm part of the OpenShift steering board. My Kubernetes is most of the time OpenShift, but many times like this one, I end up working with cloud native Kubernetes. But I'm a big OpenShift enthusiast, and I'm also a big run everything in your cluster advisor. I would love to have clusters where I can run my SQL, my caches, my Elasticsearches, my everything inside Kubernetes, right? But this is my personal opinion. Um, you need to take into account whether your team is comfortable with running SQL inside the cluster for the following reason. When you run it in the cluster, all the cloud operations are reliable on you and your expertise and your team's expertise. So this means that you actually have to make sure that you have proper backups, proper restores, that your application can handle stress and be burstable or not, and it can suffer outages. It can be brought down, it can kill the pod, it can kill the container, and so then a new one will be brought up with no impact, right? That's what a cloud provider will do with your database for you. So if you are running inside Kubernetes, you need to make sure of that. I always do. That's why I'm a big enthusiast of having them into Kubernetes. But you need to make sure that you can take care of that. If you can, then you should. That being said, um, once you have that under control, scaling it up and down, it's very simple because you understand the constraints you are following, right? You know how much memory you have, how much storage you have. Um, I have run massively big databases on Kubernetes. I mean, petabytes of data into read-write and read-only replicas with MySQL, with Postgres. So it is doable. It is possible. It's something that people are doing, but it's not because people are doing it, you need to do something. Remember, you need to abstract what matters, right? That's lesson number two. It makes sure that it makes sense for you to have that scaling power or not. Because if it does, then yeah, you can totally do that. And there are free open source libraries and operators for you to do big SQL clusters in your Kubernetes. Fortunately, we have run out of time. I really appreciate you showing up. I will go to one of the general rooms. I think I'll go to number three, and I hope I can see you there. If you have asked the question and I have not answered, I'll be more than happy to answer those there. Okay. Thank you so much and have a great conference. Bye bye.